Good morning, students. My name is Ajay Meena, and I am Assistant Professor, Department of Electrical Engineering at GIT. And today's our topic is load flow studies. We discuss about load flow studies. What is load flow? Load flow studies. Load flow studies totally based on the power system. What is the power system? Power system is the our main topic in that we study about electricity generation, transmission, distribution, and utilization also. Here we study analysis in that we include the voltage, current, real and reactive. इसमें active power and reactive power. Active power and reactive power we study this in load flow study. What is the power flow study? We discuss about this in next slide. What is power system? Power system is the combination of generation, transmission, distribution, and utilization. This is the semantic diagram of the power system. And the power system, power system study is also called the load flow, power flow study. We call this also the load flow study. We know that what is load and how it will be flow in the our transmission line. Load flow, load flow is the main part of the power system and it's totally based on the transmission line. In power system, in generation, we use the most of power plants. In that, we can include thermal, wind, solar, nuclear, etc. All these power plants for the generation of the electricity. Got it? Then always the generation of the transmission line, generation of the power, electricity is always 11 kV. We can't generate the electricity on high voltage because in this, if we generate on this voltage, then we need high costing of equipments in that, so we use the 11 kV. After that, the transmission. For the transmission, always we boost the energy. For boost the energy, what we use? We use here step up transformer. We can raise the voltage at 11 kV to 720 kV. But 720 kV isn't possible in our India. This is used only US, Russia, China, and in all these countries. We only use 420 kV voltage. You all know, guys, we are living in Jaipur city, and in Jaipur, the Hirapura 420 GSS established, where where the incoming feeders coming from Kota, Jaisalmer, etc. and Ganganagar. ठीक है? Then it is the totally supplier incoming feeders that incoming in Hirapura. So we were here. Electricity always generate on 11 kV. After then we use step up transformer for boost the energy. Boost the energy. We use the step up transformer. After then it will in 130 kV, 132 kV. It may be 220 kV. It is the transmission. For the transmission we use for generation we use plants, and for transmission we use towers large and conductors. After then we come on distribution. In distribution we can't supply directly 220 kV, 66 kV, etc. For this again we use the step down transformer. Step down transformer. What work of the step down transformer? Transformer always the reduce voltage for the supplying to utilizers. Then in this we will do step down, and again we again we will again we will use the this for utilization. In utilization we in utilization also primary and secondary utilizers. In primary utilizers you can say that in industries, hospitals, schools, and other large scales uh, industries. In that only use directly in use that directly 33 kV, sorry, 33 kV, 11 kV electricity. For small users we use only 11 kV. You all know 11 kV transmission line always used in small cities, villages, towns, and all. In this again we decrease the voltage, and for utilizers. In that utilizers, our home appliances. Again, it's become generation, transmission, distribution, and utilization. This is the main part of power system. Got it? Then again, what is the load flows? A load flow study is done on a power system to ensure that what we will study in that. In that, we use buses. What is the work of buses? What is bus? First, we introduce introduction about the bus. Bus is the point where many nodes go throughout. In that, maybe in that, maybe by bus, maybe generators, transmission line, bars, insulators, etc. Buses always use for the transmission line. You all know the about what is the transmission line. It is the bundle conductors, and in that many it's used only for the transfer the light, electricity, oblique power mainly. Transmission line mainly transmission line mainly three types. We study about the transmission line. We use the transmission line for the transmission. Transmission line mainly three types. First transmission line is small transmission line. In that, the voltage rating will be less than 20 kV, and the length of a small transmission line will be less than 50 kilometer. And what will be considered for the calculation of like as uh, voltage regulation, efficiency of the transmission line, we include we consider in short transmission line resistance and inductance. For long transmission line, we consider resistance, inductance, and capacitance. For long transmission line, also we consider the resistance, inductance, and capacitance. Then you can say, sir, what difference between medium and long transmission line? Then we can say it always divide in three parts. First, second, three. Or in long transmission line, we use the rigorous method for the calculation of the transmission line efficiency and voltage regulation. Got it? Then here we discussing about the transmission line types. First is short transmission line. In this, the voltage rating will be less than 20 kV. Got it? And in this, length will be of that small transmission line less than 50 kV, 50 kilometer, sorry, 15 kilometer. And we will consider for calculation efficiency and voltage regulation, resistance and inductance. In small transmission line, always we avoid the capacitance due to the small length, because in in small transmission line in small transmission line in small transmission line, the length of is less, so capacitance will be here less, so we consider only R and L. Then again we come on the medium transmission line. Medium transmission line. What is medium transmission line? The medium transmission line is that where the voltage rating is less than 20 kV to 20 kV to 100 kV. It is the voltage rating that we use for the medium transmission line. And in this, the length of the transmission line will be 50 kilometer to 150 kilometer. And we consider we consider we consider the capacitance, resistance and inductance for find out the efficiency and voltage regulation. In this transmission line, we know in this transmission line we know first, second and three types capacitor used. How it will be used? First method is known as the and capacitance method. Second is the, we call this T nominal method, and third is pi nominal method. All these methods depends on the capacitance, where we use capacitor in transmission line for the find efficiency of transmission line and calculation for the voltage regulation. In this, in medium transmission line, the first method is our and capacitance method. In this, the transmission line, it is our transmission line. In this, it is the Vs, always sending end voltage, and it is receiving end voltage. Then we use the end capacitance method. In all transmission line, we use the capacitor always parallel in the end of transmission line. This method called end capacitance method. And second is second method of our is known as the T nominal method. In T nominal method, we use the always mid of the transmission line R, L and C. C always used in the center and mid of the transmission line. It always called the T-nominal method. Then the third is binomial method. What is binomial method? Always the capacitor will used starting, mid and end of the transmission line. Everywhere the capacitor will be used. You can say that in starting capacitor, then in and also we include the capacitor. As soon as, okay, got it. This is all in the medium transmission line. In this, length will be 150 less than, okay. Then voltage will be 20 kV to 100, and we consider all in this. Then we proceed to the long transmission line. Long transmission line, long transmission line used for the high voltage. In that we use the large scale conductors, towers. In towers that we use suspension type, many types of towers we provide for the long transmission line. In this in this transmission line, the length will be above greater than 150 kilometer. Voltage rating here will be our above 100 kV, and we consider here R, L and C. C is here calculative by the rigorous method. We will discuss about the rigorous method in next slide. Then totally of the transmission line performance. This process called as all transmission line performance. In for performance of the transmission line, we calculate the efficiency and voltage regulation. Efficiency and voltage regulation, where both we consider. In our transmission line, we know that we are sending end voltage and we are receiving end voltage. Then what is the voltage regulation? Voltage regulation always called the sending end voltage, difference between sending end voltage to receiving end voltage. And then in this you can say here difference between Vs minus Vr. Okay, got it? Then Vs minus Vr divided by Vr into 100. It is called the voltage regulation. Got it? Then again we calculate the efficiency of transmission line. Efficiency always depends on input divided by output. What is here our input? Input is here sending end voltage. This is our input. And what is the output? Output of this transmission line is our VR. VR is the receiving end voltage. VR is the receiving end voltage. Then we can calculate the efficiency of transmission line easily by the use of this formula. What is that formula? We will calculate the formula. Our formula is efficiency. Wait a minute. Efficiency is equal to input by output, and we can say that efficiency is equal to Vs IR Vs IR cos phi divided by Vs Is cos phi into 100. We consider here losses also. This will be the efficiency of the transmission line. Then again we go to next slide. I already told you about bus bar voltages. What is the effect of on load flow studies? All are their optimum system losses हो गए, rating and tape rating, tape range of transformers. Then it is the load flow equation. What is load flow equation? In load flow equation, we use a bus system. Our bus system may be 3 types, 4 types. We, we include the many type of buses. Here is 4 bus system, Y1, Y2, Y12, Y13 and Y14. What is here? This is Y1 is 11, 12, 13, 18 is the bus admittance matrix. Then Vi are the bus voltage. What is here? I1, I2, I3, I4. All are currents injected at a node. I already told you before, bus is the output of the signals. Then the equation written by II is equal to summation Yij Vj. Got it? This is also the active as total bus system is as equal to Pi P plus jQi. P is here active power, Q is reactive power. Then this is the all derivation about the active power or reactive power. This is the P. P is equal to, P is known as, this is the equation of cos phi, because active power always defined in cos form. These all are the method of these. We include in magnitude, phase angle, active power or reactive power. What is the bus? Here is the types of buses. Buses type is slack bus, load bus or generator bus. In this, some variables are defined and some are not defined. Sometimes active power defined, sometimes reactive power defined. We consider all and we calculate everything. Then today's our discussion is here stopped, and thank you so much for present here, and good luck for next class.